Hello, everyone, and welcome back to the YouTube channel, An American Professor. In this video, I'm going to start getting into the rhythm and flow of reinforcement learning a little bit, and I'm going to show you where I blog over at Medium. I've written a number of articles on there. We're going to start with this one called Framing Tic-Tac-Toe as a Reinforcement Learning Problem. Eventually, you will learn enough about Python in order to program a reinforcement learning agent to play the game of tic-tac-toe. How fun is that? First, I'm gonna synergistically go between YouTube tutorials on Python and reinforcement learning. But this is more mathematical, but I'm just gonna step through it. So if you're interested in keeping up with me in my writing, you should definitely follow me on Medium. Got about 505 followers right now. My short-term goal is to cross 1,000, and long-term goal is to get into the top 10% of writers on Medium. And the way Medium works is there's a number of topics. It's broken down into topics, so you can write on reinforcement learning, machine learning, AI, programming, coding, Python, anything you can think of. There's probably a topic for it. So for this video, let's overview what is the formulation in terms of reinforcement learning to play tic-tac-toe. Like, what is the setup? We know it's a 3x3 grid board for playing tic-tac-toe. Each player has a set of X's, and another player has a set of O's. For this series of videos, we'll take the stance that player 1 is X's and player 2 is O's. So furthermore, agent 1 moves first in every game. So we have a well-defined order and progression through each game. And no game will take more than 9 moves. If it takes 9 moves, that means it ends in a draw and no player wins. So that's another thing to think about for tic-tac-toe is it's episodic. Each game is a new episode with 3 possible outcomes. Either agent 1 wins, or player 1, or agent 2 wins, player 2. Or there's a draw. Neither wins. Neither player 1 nor player 2 wins. And we can pictorially represent the tic-tac-toe board and by this 3x3 grid, where I have denoted each cell with a number from 0 to 8. This is important because this is going to feed into our state space model. We're going to encode the state as the whole board. And if player 1 puts his X down, that'll be denoted by 1. And if player 2 puts a circle down, that'll be denoted by 2. And if the space is empty, we'll denote that by 0. So doing some simple counting, we can see that the state space size is 3 to the 9th, or 19,683 possible states the board could be in at any given stage of play. So the way I'm going to think of the board as this 3x3 grid, similarly, I'm also going to think about it as this 9-dimensional vector. It's a 9D vector. Now that we talked about the state space, we can talk about the control space formulation of tic-tac-toe. So at any given player's turn, they can put their respective marker down if no other player or its own symbol has been placed on a given cell. And I denote the set of possible controls by script U and a time index for the subscript. So at time 0, the possible controls are 0 through 8. That is, we can place it down at cell 0 through any cell up to cell 8. And that's where these indices are useful, is actually not only in terms of the state space description, but also the control. Because if any of these indices are in our control set, it's the possible viable control. If it's not in the set, that means it's occupied by either agent 1 or agent 2's marker. And each turn, whatever move agent 1 or agent 2 takes, here I'm using superscript to denote agent 1 here, and here agent 2. And similarly, as for the control set, the subscript denotes time. And you can also have an is done flag in your program to denote when the game is over. Now I'll explain the coding while this now. Right now I'm just setting up the mathematical description of the game of tic-tac-toe for a reinforcement learning agent. In the upcoming video on this series, player 2 will be irrational. That means it will just have a random policy. It will not be learning from agent 1's play over time. In the future, I will consider agent 2 to be an RL learning agent, as I am currently considering agent 1 to be the only rational or RL learning agent. I say it's rational if it's applying some reinforcement learning method. It's irrational if it's not learning from the history of the play. Now for the environmental dynamics, it's very simple. F is a deterministic function. There's no randomness. Player picks a place that's empty on the board, and if it's available, it puts it down. It's that simple. The reward model, you can put any positive reward you want for winning the game, and I use 0 reward for if the game ends in a draw or player 2 wins from agent 1's perspective. Now this is pretty sparse, and in future videos you'll see that I have to come up with a way to fix this sparsity of rewards issue. But for now, I'll let you think about that. And if you want to never miss one of my stories and keep up with what I'm writing, feel free to join Medium using this link. You'll help support my writing. I get a fraction of your membership fee when you join, and Medium gets the rest. But Medium is great if you want to learn more about AI, reinforcement learning, data science. There's lots of good material and content on Medium. Look forward to seeing you in the next video. Don't forget to hit that like and subscribe button. Have a blessed day.